Okay, we're going to continue with an informal discussion of measuring distance in Euclidean geometry, and we're going to investigate a couple of more topics that are related to this. So once again, we have the distance between 2 points is the same as the length of a line segment with those 2 points as endpoints. So for example, we can take this curve AB, which is a line segment, a unit line segment, and it has a length of 1 centimeter. So we can take that as our basic unit length. And what we want to do when we're measuring lengths is we want to see how many of those little segments we can line up end to end. So if we have a line segment, like the line segment CD, we can measure that by counting how many of these we can line up. 1, 2, 3. This is controlled by this parameter here, so if I want to make that bigger, like 4, or smaller, like 2, I can do that. I can even make it a fraction if I want to, but let's go with 3. Okay, and so it has the length of that. And by the way, notice whenever I change this number here, it is changed dynamically over here in the sketch. So kind of a cool little feature of Geometry Sketchpad. Okay, so anyway, we have this line segment CD. We can measure it by basically seeing how many copies of AB we can line up end to end. And so that's basically the idea of a line segment and of measuring its length. So that's distance or length. So it's the distance from C to D, or the length of that line segment. Now, one of the main ideas that's really basically behind Euclid's first postulate is that we can take a line segment and extend it indefinitely. So, for example, we could add a point X and a point Y on each end there, so that this distance, so that we're adding another unit length here, and now we have extended this to a longer line segment. So, of course, we want to do this in such a way that it stays straight. And so all of these points will be on the same line. And this is sort of informally the idea behind extending a line segment. And of course we can do this as many times as we want. Of course we don't have to add a whole number of line segments each time. We can add just a little bit or a lot. And in fact we can do this indefinitely, so we can extend this essentially forever, and now we get an entire line. Okay? And again, this is the idea, is that we can take any line segment, extend it to any longer line segment we want, and in fact extend it all the way to a line. Okay, let's go back to our original segment here. We can now define, since we have distance, we can define a circle. A circle is going to be the set of points in a plane which are a fixed distance called the radius from a given point called the center. Okay, so for example, let's take a radius of whatever this length is and centered at the point C, and let's build a circle there. So this is a circle here. Alright, now a line segment with one endpoint on the circle and the other endpoint at the center of the circle is called a radial segment, so that's going to be another definition. And so I could show you a general radial segment here. So it goes one endpoint's on the center of the circle, the other endpoint can be on the circle itself. Notice that this segment is the same length whether I put it here or any way around. It's the same length as whatever this length is up here in centimeters. So this is at the moment is 3 centimeters long no matter where I place it. So you can see that the circle is legit in the sense that it is the set of points that are the same distance out. Now, of course, one of the things that this assumes is that you do have a consistent way of measuring distance no matter which direction you're pointing. And that's a really important idea in Euclidean geometry. For example, it's not true in taxicab geometry. Now, notice some people, I think, use a little poor terminology here. They use the term radius both for the length of this segment and for the segment itself. And I guess if you know from the context which you're talking about, that's okay, but you're using the same word for two different things. A radial segment what I'm calling a radial segment is a set of points. It's a line segment, whereas a radius is the length of that line segment, which is a number. And we're going to make a distinction in our treatment of geometry between numbers, which might be distances, and geometric figures, which are sets of points. Now notice one thing that some people get confused about, beginning students particularly, is that the circle is the set of points that are the blue points here, does not include any of the points like the center or any of the points out here. So the set of points that are whose distance from the center is less than the radius is called the interior of the circle. So those points there are the interior of the circle. And then the points out here that are unshaded, those points are called the exterior of the circle. Now, when we're talking about measuring length, we don't have to necessarily follow a straight path to measure length. We don't have to be measuring line segments. So, for example, we can maybe look at a curved path like this path right here, which is a path along a circle. Okay, so where we only have that path right there. Okay, and we can see the red path here. It still has a length of 3 units. So what we've done is we've taken our line segment here and we've placed it along here, but we've bent it without stretching or compressing, but bending it. So think of it like a piece of wire or something that you could bend, and bending it along there, we see how many of those bent pieces we can line up end to end, and again it's 3 in this case. Okay, so that gives us a nice little informal introduction to some concepts and some basic, some formal definitions of circle and let's see what else, circle, center, radial segment, and so forth. But it also gives us an informal way of looking at how we measure distance.